Welcome to my talk about better in-app billing testing on Android. So we call this Register at the New York Times, and I hope you'll try this library at the end of this presentation. So what is Register? We'll get to that. My name is Walter Dziemianczyk. I'm the random stranger on this stage, and I'm an Android engineer on the Reader app for the New York Times. Our team at the Times has been working and has released this library to help you with testing in-app billing on Android. So this coincidentally is the library that I'll be talking about. So I guess a little bit of a summary of testing, I guess. So you have unit and integration testing, right? And that is easy, I guess, for you, the developer. You know the code or the system like the back of your hand. That means you know all the test cases. You know what you should expect. In a perfect world, you would, and there would be peace all throughout the world, and there would be no world hunger, and there would be no such things as bugs. Except that's not true, and bugs are a real thing. There are limitations to your unit testing, and that is you, the developer. You will run into situations that you hadn't accounted for. So QA to the rescue. Espresso, I guess the summary is that you're validating some UI on the screen, an activity shown, or you have a list of a certain amount of items that contain a certain sequence of text. So within the Times app, we have a Espresso test for validating all the section list items you have in the drawer. But what if your UI is correct and you have that data on screen that is valid, but there's another sequence of data that's displayed that's not? Technically, that test passed. Maybe the server spit out some data, I don't know. Something was weird on the server side, and it gave you something that it did want and it didn't want. This is why we have QA, right? They're the people that will catch those sort of things if you, the developer, don't catch them when you're developing. They basically catch all our mistakes. So this is some fake data, as you can see on the bottom. So QA is another set of eyes. That's why I put optometrists there. And they're another way of breaking things, which is good because we need to break things. The more that breaks for you during development or through QA, the less that breaks for the user, and that's the most important thing. So if you want, please use this statistic. Give it to whatever stakeholder wants to hire QA, and it should work. So in general, QA acts as a firewall. So for me, that's what I think of QA. If it gets through my testing and my development and my unit tests, they 98, I guess, % of the time catch some critical issues. And it's really such an essential part of our teams at the Times. It's another way of saying it's, I guess, the last line of defense. So basically, I went over 3 ways to ensure that your code works. So first is unit testing, which is testing, single components, classes. You mock a bunch of stuff that that class is dependent on. Then you have integration testing, so you're testing flows, so using Espresso. And lastly is QA testing. So QA testing is, you're building a brick wall, they're the mortar, they fill in all the gaps, they do debugging, they provide some VQA, they're that firewall. And I guess the fourth is during development, but that doesn't really count. So another added benefit of QA is that they file Jira tickets for you, which is super convenient because no one likes to do that. So we talked about testing, but what does that testing surround? So why am I talking about this? And why do we want tests? Why even write tests? Why not save time by not writing tests? Because that sounds like fun, right? So user flows. we have our section front, which is the main screen of the app. And we have our article screen. And you click something within the main screen, the section front. That's usually an article. And it goes into that article activity, and you read the content. So we want to make that sure. We want to make sure that works. So Espresso test, right? Integration test. We have a settings page. So making sure that the user is able to change whatever preferences that they want, say notification settings or offline settings. We just pushed the feature to add a save action to a breaking news alert. So making sure that works. Next is, I guess, finite features. So we have an audio indicator within our app. We have to make sure that it plays and pauses audio. We have to make sure it accounts for audio takeover. You start some piece of audio, you click on another piece of audio within that main screen, making sure that that takeover works properly. UI transformation. You click on our bottom right little audio indicator. It disappears with a neat little animation, and it comes up as a drawer, making sure that works. And then we just released a podcast screen within our app. So that podcast screen is reliant on our audio indicator, I guess, code that we already had. So making sure that same functionality is still there. So that's, I guess, the basic stuff. And then you get into critical things. So login. You want your user to get into your app as quick as possible if they're already a subscriber. And you want them to start consuming content as quickly as possible. You want as little friction to get them into the app. So that same thing applies to account creation, right? You want kind of like a shortish onboarding screen, but you really want to get them into our main screen as quick as possible. And it's something super important for a newspaper because that's our bread and butter. So the last thing is purchases. If you're selling something, that's probably going to be the backbone of, how you get paid and how you support the development of this application. So go into purchases. There's a theme here, I promise. A good call is probably to think that this is the most critical thing in your app. Because if you don't get a subscription or a purchase within that subscriptions page, then your company will get no income. And then you get laid off. And then you become a beggar on the street, or worse, you work in consulting and then you have to deal with clients. And nobody wants to deal with clients, trust me. So that's the little Italian that I know. It happens. I mean, a bug is going to be introduced, and a purchase may not be made. Maybe you have a poor connection. Maybe a server's down. If anything fails, that's less users or less subscriptions, and that really stinks. A good mindset to have is, do we ever have enough tests? And the answer should always be no. And if you need to, you add more tests, via unit or integration, or QA makes more test cases. So testing purchases on Android. I call it a land filled with limitations. So there was a talk yesterday by Sebastian Gottardo where he talked about the state of in-app billing within Android. And he went over some of those limitations, so that was a good precursor to this talk. So the first way you can accomplish this is through static responses. So static responses, No? Yes. Cool. In a nutshell, you have to pass specific, special product codes to get a response. So each product code or product ID returns a specific static response. So Google provides 4. There's purchase, canceled, refund, and item unavailable. So you can only use these 4 codes with the request purchase flag when you're generating that request. And then the actual product codes need to be used only for subscriptions, so you can't do integration tests. So option number 2, test purchases. So in a nutshell, still got it there, good. It's a more powerful approach, and it interacts directly with the Play Store. So you don't have to use a credit card, nothing's getting charged. They're not real tests, which is great, because you save your money. You can buy more coffee with it. So the downfall kind of is that you need to publish your app within the Play Store. So that doesn't mean it needs to go into production, but you still need an alpha build or a beta build. And that means whenever you're developing this and you get to this screen, you have to stop. You have to set up the dev console. Then you have to set up the alpha and beta group. And it's just a headache. You don't need to. You don't need to do it. You have to make sure that the same package that you have uses the same package name. So if you do something like an application ID suffix in Gradle that appends .debug to the end or whatever your suffix is, like that's not good. Your products must be published in the Play Store, so you have to have products within there. So some fields will be locked when you create them, and they can't be unpublished, so that's a bummer. And they can only be done, purchases can only be done by testers whose Gmail accounts have been registered in the Google Dev Play console. So if you're working on this feature or you're testing this purchase flow, it's fine. But if someone outside, maybe it's a stakeholder or your manager, maybe you do have QA, you then have to stop what you're doing, set them up, and that's less time you have to develop. So quick development, not really a thing. Purchases could take up to 24 hours to be removed. There's some other limitations of time frame. I think if you cancel subscriptions, if you have a yearly subscription, it could take up to half an hour for that change to be reverted. And lastly, there's happy path testing. So there's no way to test how an integration handles a failed call to a method like getProductDetails. So more fake data. So what is one to do? If there's only an app, an open source app developed by the Times, library, that worked to fix all these issues. And I really wanted to do like a Star Wars thing here. I'm not really a Star Wars fan, but I'm kind of a little new to Keynote, so I kept it simple. So register is what that thing is. So register is an open source library. It's also a companion app, kind of like Leak Canary has their companion app, and allows you to seamlessly mock responses from Google Play's in-app billing. So open source library and companion app. So it's licensed under Apache 2.0, so you can do whatever you want with it. If you want to clone it and fork it and make it a ton better, you can. Do whatever you want with it. Hopefully you'll contribute back. That would be great. So it kind of works like a mock web server. If you ever used it, same idea. You bundle your products locally within the phone, and then you point your app to use a class that's provided by register. And then you're all set. So it's simple. A simple implementation makes it easy to integrate into your app. And we'll go over that implementation shortly. So there's the code, and then there's the companion app. So the companion app, you can control the state of your purchases, and you can control response code for those same purchases. So how does it work? With hammers, of course. No, just kidding. So InApp Billing uses AIDL files to call onto Google Play's app service, and then we do something similar to mirror that AIDL file within register. So this is class number 1. This is the real one, Google Service Provider impl. So this, any request or call onto this class's methods passes through directly to the Google Play app service. So then we have the fake one, which is Google Service Provider testing. So this works against, no, back up, there we go. Thank you. So this works against a second AIDL file that I mentioned earlier. It's the same interface with a different package, and its calls are handled by register service. So the data, how does each one get data? Passes through to Google, and it fetches products that you have defined in the dev console. And this is the Google Service Provider impl is what you'd use on release builds. The fake one points to a JSON file that is sourced from the phone. So you define your products within there in JSON. That instance is called Google Service Provider testing, the one that I just, last slide. And that's what you'd use for debug builds, or if you're sending that to somebody else, QA or marketing or whatever, you'll point to that instance. So you have a third class, and that's called the Service Intent Helper. And this is what you pass in your context, and you pass in the Google Service Provider, whether it's the real one or the fake one, and it spits out an intent, and you use that intent to connect to the service. So let's talk about setup. 5 easy steps. I feel like I'm selling a blender, but anyway. So let's talk about that JSON file. So this JSON file needs to exist on the root of the SD card. So this example, it's a little limited because I needed all this code to exist on one slide. But you have an array of users, which is your purchasees, and then you have your SKUs, which are your products. So this one only shows subscription, but you can have an in-app purchase, and that's about it. So within this sample app, there's a register.json file, and you can take a look at that and modify that however you'd like. So next is the infamous Gradle import statement. So if you're It's kind of simple. So if you're not using Gradle 3 and above, then you swap out implementation with compile, but that's all you need to add. And then the companion app. So the companion app exists within the releases tab of Register. You take that APK, you install that on your device, and you'd also have your app running alongside of it. So you can, install the APK through ADB, or you're on your mobile. You can download it through GitHub through this link, or Solid Explorer, I think, lets you install APKs too. So now it's time for some code. So first function returns the Google Service Provider instance that you want, whether it's the testing one or the real implementation. And then you call the Service Intent Helper to spit out an intent. You use that intent to connect to the service. So you can inject this via Dagger. This was just, simple. You can also use like app prefs if you want it configurable. That's something that we do. So then you run it, and that's it. Magic. Like I said, that's it. So let's get into some fancy videos. So we have our buy activity whenever you're in your app. This is a way long GIF. That buy dialog pops up on top of your current app. And within there, you can change the purchasee, that bottom array, to whatever email you want. And that information will be displayed within the receipt, which is conveniently right there. So you can swipe up. This is a super short GIF, and I swear I just cut it off. But you can swipe on whatever the receipt is, you delete it, and then it shows you an empty state. But I forgot to change that GIF, so I apologize. And then lastly, configuring responses. In this example, I changed the response for code for buy, and it spit out an error within the sample app. So you can easily toggle, like I mentioned before, between the fake one and the real one using shared prefs or by build type or inject it via Dagger, whatever you want. It's all on you. So back to that firewall, right? So this project, this library has worked really well for us because now it lets QA fully test their purchase flows and not be limited with all this overhead. And it, I guess, allows their test cases to be a bit more granular. So this library makes that functionality possible. And then it's easier to develop because now I can just point to this fake instance, run through my purchase flow, same way QA would, and then swap to our companion app, delete the purchase, and rinse and repeat. So for myself, it adds more time for development. I don't have to deal with the dev console anymore. I don't have to add any more emails, and I can execute multiple test cases that are in my brain without having to recompile my app or change something in the dev console and wait for things to change on their side. So anyone can use this. You aren't limited to being online or having a Google account or being a part of an alpha or beta. Now I can just, if I'm making like a test build for somebody, I can just point that build to use our testing, the Google Service Provider testing class, and send that build off, and then that person doesn't have to deal with anything. So the version is very low, but don't be worried because we've been using this library internally for around 2 years. We just did a low release number because we just did. But I wouldn't really worry too much about it. Nothing really has changed. And it's a fairly stable API. So we need your help. If anybody's looking for some really valuable internet points, please take a look at the repo. If you have any suggestions, please make them. So we can do something like having no JSON file, which would be great because that's one less step. Automagic companion app installation, like what happens with Leak Canary. A purchase history. Google Play billing library support. And you can being able to edit products within a companion app. Lastly, we can also make a ticket for helping me with keynote animations because mine are, might need a little bit of work. So those are the big things, but there's still a lot of little stuff to do. So a short but semi-exhaustive list, multiple currencies, languages, expirations, free trials, intro prices, receipt verification, just to name a few. There's still a lot of work to be done, but we have a lot that's there. So please create an issue. Go to GitHub, NY Times, register. Create an issue. We'll talk about it. We'll figure something out. If you want to see something, put it there. We'll work through it. And you also have to make an issue if you want to redeem those internet points. You can also reach me at my Twitter handle. I'm pretty active on Twitter. I don't really post a lot, but I've been making a habit of doing that. So you can reach me on there as well. And thank you.